Thank you all for making it. I know that some of you had to travel from track 3, which I'm surprised you didn't take an Uber or something. And some of you made it from track 1, which is not...
This is track 3.
Sorry. Blame the dyslexic guy.
Oh, it wasn't a joke.
Track 2, which feels like it should be track 3 now. But anyway, thank you all.
Thank you.
You've all ran out of Andy's talk, so I hope it was good. Last time I saw him, he was getting shot with Nerf guns for swearing.
Brought the Nerf guns.
This is a talk where I'm not supposed to swear. And if anybody's seen me talk over the years, please feel free to take a sweepstake to see if I can actually do it. Andrea doesn't swear, so this is kind of the yin and yang of colourful language. But anyway, for you guys that don't know me, my name's Finux, and...
I'm Andrea. I'm a lead information security analyst at Sainsbury's, and you'll probably see me around lots of B-sides and things.
Cool. I guess we go on to the next slide. A little bit of a shout out to a fallen brother of ours, Mike. The reason that me and Andrea know each other is through Clappy Monkey. There's a lot of faces in here that I know will know Mike. Some of you might not know Mike. If you ever get a chance to speak to anybody that does know Mike, Mike was a bit like JFK. You know, culturally everybody knew where they were when JFK was shot. Everybody remembers where the fuck they were when they met Mike Kemp. I've already sworn once. I'm super sorry. Don't shoot me. But he passed away with cancer about 6 years ago. So we come in. There is still seats. Don't worry. That's all right. You can be the third speaker if you like. So we and Andrea just wanted to take a moment to remember Mike. He was a close dear friend of ours.
Right, so we're going to talk to you about threat modelling today. After meeting each other through Mike, it's a topic we found we were both interested in. So then we started discussing about possibly giving a talk together. I really became interested in this through using it in my work. And when I joined the organisation, I was looking in our sort of cloud consoles and seeing all these alerts about bad configuration. And then one day, one of my developers came to me and said, we're going to refresh this particular, what we call a capability we use for getting data from systems to the data warehouse. And that capability was the one I've been seeing a load of these alerts from, because every S3 bucket that had been made from that Terraform had the same string at the beginning of it. And so I knew where they were coming from. And when they said that they were going to refresh that, I thought, hooray, we can get rid of all these alerts and vulnerabilities and configure it properly. And so that's when I started about using the Microsoft threat modelling tool to put some things into that to help with that secure configuration. And so that's really led to the talk today, just really to kind of bring that home and how it can help. But, I'm sure that you probably see this all over the place, just so much bad configuration going on that could have been sorted out at the beginning. There's something we'll look at a bit later about why that happens. And, your pen test come back and there's quite a few findings in there of things that you thought, well, surely isn't that a basic thing to do? And, there is a risk from that, isn't there, about kind of alert fatigue?
Yeah, I'm preaching to the choir, I'm sure, but most of you will have experienced alert fatigue. We do it with cookies all the time, let's be fair. That's all we did is teach citizens to press OK this minute that they go to a web page. But I once did a pen test, surprisingly, at a company, and we got PS exec running with domain controller and rained down about 350 shells in about 90 seconds. They had Sophos on site, and I've never been a big fan of Sophos, but they are going to detect 350 shells loading up that quickly. When we did the wash up with the head of IT afterwards, I said to him, "What did Sophos say?" And he was like, Right, so there was an increase in intrusion attempts. We thought it was a false positive. Not really, but But this is what happens: that we do so many alerts that in the end we become blind to them. But you guys already really know this.
So, just to kind of bear out this fact, here's the latest report from the Cloud Security Alliance on top threats to cloud computing. And as you see from that, misconfiguration and inadequate change control is a major factor there. And identity access management is normally something that you should think of at that configuration stage as well, isn't it? Your insecure development, using out-of-date libraries and things. And APIs, so another thing that comes in that sort of configuration sphere. So all of that really is covered by those things that we see day in, day out, of people not putting that effort into properly configure their infrastructure. And there's an example of some of the biggest data breaches we've had recently and what was behind them. And so again there, you see that most of those really are poorly configured stuff. It's not some software vulnerability, some 0 day. It's just people not building things properly. Apart from the bottom one there, of course, where it was a 4-year-old Apache struts vulnerability that hadn't been patched. So yes, that happens as well. And, but why do people leave these things that long and then get compromised? And so I think a lot of what's behind this is the fact, just like with so many platforms, MFA wasn't standard. And, it's not until more recently that Microsoft, for instance, have suddenly realised, oh dear, everyone's Office account is getting popped. We'd better enforce MFA by default rather than leaving it up to you. Because if it's left up to us, we don't change anything. We just get in the easy way, don't we? And think our password's strong enough and whatever. But so much other, especially like cloud infrastructure, when you spin it up, it's got lots of things on it which really you wouldn't consider as the best sort of security default, like having a public IP, public access enabled, that sort of thing. And so it's not until you actually go and read up on all the best practice configuration that you then realise, oh dear, this thing I've just built, I haven't got the best settings on this. Another one is, for instance, Azure Storage. By default has shared access keys. Not the best way of looking after your Azure storage and controlling access. And, when you've got kind of managed identities and things you can use in the platform. But that's what happens by default, and you probably see lots of those around if you've got any Azure infrastructure. And so why does this happen? Well, I did some research. I did an MBA recently and did my final year dissertation on the cultural and technical barriers to reducing cost in the cloud. I didn't look at security, I was just looking at cost. And I sent a questionnaire out and let any developers who wanted to answer the questionnaire. And I got 45 responses, which I thought wasn't too bad. And there were some interesting themes in their responses to my question. But one of the ones that came out that ended up being the real theme of my dissertation was the fact of, well, we don't put the effort into building infrastructure in a way that will save money over the long run, because we just want to get the thing working. We just want to quick and dirty, get it done. And it's that, whole thing, of Finux, if I give you €500 now, or €2,000 in 2 years' time, what are you going to take?
I'm going to go with that now.
Yeah. And that's the sort of response everyone gives. They don't want to wait for something that would actually be a much better return. And don't you think that's the case with security as well? We don't put that effort in. We don't look ahead to all those benefits it could give us in the long term of a much more safe system, secure system. Because where's the incentive? We just want to get the thing working, keep our product managers happy or whatever, and produce the product the company works so that they can get on with business. So, I wanted to kind of make things easier for developers so that this chore of getting things built securely, getting the kind of secure design there, was not such hard work for them. And if you can do something to perhaps hand some of it on a plate to them, then maybe they'll go ahead with it because it's not going to slow them down so much. Over to you.
So kind of the threat modeling thing here is, this is kind of an age verification, by the way, right? So I know that some of you will have known this quote, and some of you will be like, who is this guy? Interestingly enough, Assange will know who he is, and that's how old I am. But basically, they are known knowns. They are things that we know about. They're things that we don't know about. This is really threat modeling, right? Like, in a lot of ways, they are things that we know about. They are unknown things that we can predict. And I kind of love the Rumsfeld quote here about it. I jumped ahead a slide. But like I say, this is kind of the quadrant that Andrea has put together to kind of show you the sort of stuff that goes along with that.
And yeah, one of the particular things I think here is the unknown knowns. And I think that's the thing that doesn't get done. Because when developers are building things, they do that top left quadrant, the not known knowns, the things that day in, day out they would put in place. But then there's all those things in the best practice and that they are known and it's there, just they're not in the top of the developer's mind and they're not going to spend the time searching them out perhaps. So they often get neglected. The known unknowns are more the sort of things like the 0 days, the human error. The stuff we know does happen, but we just don't know exactly what sort of thing it'll be. So we can sometimes think a bit about how we can mitigate those types, things like backups and whatever might be an option there. And then you get the just totally weird, and that happens very rarely, but obviously does happen.
What I would say, though, just to interject a little bit with the known unknowns, is threat modeling gives you the opportunity to kind of simulate what that would be. You don't actually have to have a 0 day in a system to understand what the impact would be and how to start working on mitigations. You don't have to wait for the walls to fall down before you start repointing again. So there's kind of like, there's some benefits here of not getting caught up in details and just accepting kind of like, we're going to be popped at one time. That really. And of course, the unknown unknowns is we can all be forgiven for getting popped by stuff that we don't know about, right? But it is definitely the stuff that we do know about that we get popped for, that we're wrong for. Okay, yeah. And just to finish off the quotes from random old people that you may or may not remember.
Same era.
Absolutely This is when you put one foot in your mouth, you should follow with the other foot and keep on going. I'm not sure if anybody remembers this, but this is that old saying from Tennessee: "Fool me once, shame on you. Shame on you. Fool me, you can't fool me again." To be fair, though, he was the last good Republican president of the US, which is fucking worrying. Oh, Jesus, I've done it twice now. I'm sorry. But threat modeling gives you the opportunity to play the home field advantage. You are aware of your systems. There is a genre of hacking that is kind of like offensive threat modeling, where kind of adversaries will do threat modeling against you to understand where to start attacking. This kind of sounds like information gathering, versioning, and footprinting. But really, the logic flaws that are involved in this, are kind of useful. But as a defender, we have a lot of advantages. Like, you can almost have a look at it in kind of taking this 2-step forward mentality. Do you understand your assets? Take 2 steps forward. Have you got an inventory of what you've got? Take two more steps forward. Have you got update policies? Take 2 steps forward, so on and so forth. And eventually you see in this cyber arms race that you are already 20 steps ahead of your competitors just because you sat down and started thinking about it. Having worked with developers, I worked with developers for a software agency for a little while, and your security exponentially increases the minute that they start talking about security. It's not rocket science, but developers don't wake up in the morning and think, lol, let's make something insecure. I may feel that way from time to time, but at the end of the day, the truth of the matter is that there's a lot of different things that are pushing them. They're not focused in that area. It's not context dependent. We also know that in security and hacking, like it's not one of these easy to jump in, easy to jump out kind of contexts. So getting developers in earlier and in the threat modeling process helps them start to come across and put ideas into place to help us make their systems more secure. Be careful, though, asking certain developers what could go wrong, because that can be a really long question. Being neurodivergent is a bit like, say, tell me that you've got autism without telling me you've got autism. What could go wrong? And that's probably our job in security, to kind of just weed out what's real and what's not. Although, don't forget that likelihood low, impact R high still happens. CrowdStrike is a great example from last year. Likelihood low, impact incredibly high. But as I say, that, it's hard to threat model that really. I mean, you can work out mitigations. One of the things that, just as a side note while I'm thinking about it, one of the things that's not the same but is the same when I talk to clients is I talk to them about writing offboarding procedures for their suppliers when they're writing onboarding procedures for their suppliers. So that they're able to work out their mitigations. They're able to deal with vendor lock-in earlier on. They're also able to make sure that the supplier is aware that you could leave. So I've been doing this for a long time, probably I say a long time, about 5 years, really trying to get customers to write their offboarding for their suppliers at the same time that they onboard them. Because as I say, it will give you benefits in the long run. If your supplier goes popped, if there's a problem, you know what the mitigations are because they're kind of the same as your offboarding procedures in some ways. So threat modeling gives you that home field advantage. It gives you the ability to try and predict the future. And really, it gives you a map of where the dragons are. Now, it doesn't find all things, right? And that's because we don't have enough time. That's because we don't have enough resources. We probably don't have enough will. And plus, we have an imagination barrier and a bunch of this stuff, too. I mean, sometimes we just can't predict everything that goes wrong. But having something to start focusing on and saying, this is where the dragons be, let's start working towards that, is super beneficial.
Yeah, so first step in doing a threat model is to think about what are you designing. And you can look this up on the internet if you want to get some information on the threat modelling process. Then if you look on OWASP's website, they've got a threat modelling process on there, which is quite self-explanatory and how to follow it. So data flow diagrams, we just draw basic processes out in the way that they're connected. And you can go through the levels so that your web application, if you were actually threat modelling that because you hadn't previously done it, you could break that down further into any components within it. But by showing where your data's flowing and where everything sits, you can think about the trust boundaries, which are those areas where an attacker might attack your system.
And those trust boundaries, like if you're getting a pen test, not doing one, but if you're getting one, they're a really good place to also start thinking about threat modeling because, one person's pen test is another person's vulnerability scan is another, so on and so forth, right? And really what we have, I've heard this term used a couple of years ago and I absolutely love it. Pen testing is a paid-for capture the flag event in most cases, right? And what we're doing is testing the tester against your security tooling. So they go in and how do we traditionally know that something's insecure? Well, it's the amount of vulnerabilities we find, right? And how do we know it's secure? Well, we find less vulnerability. But the problem is we change the tester, we change the results. So you put in a pen tester with 20 years experience and they find 90 vulnerabilities. Oh my God, we've got an insecure application. We put in a junior who finds 3 vulnerabilities and we're super secure. And that, there's two types of people in the world. People that go, oh, and people that go, oh. And, you can cook the books a little bit with this, right? But in some ways you can use threat modeling to be a little bit more useful in pen testing to say, okay, these are the type of threats that we expect to see in these trust boundaries. So, we can take one of these dotted red lines and say, okay, I want our pen testers to work on spoofing, so on and so forth. Repeatable tests that give us an actual idea about what we're trying to get back. And while it sounds like this should be common sense, it isn't common sense in my experience. Maybe different for you guys, but in the end, we probably get a lot of spray and forget going along pretending to be pen testing. May have been guilty of that once or twice myself, but whatever. But in the end, going through that and working out what types of threats, doing those tests and confirming that either our mitigations work or our tooling works, our logging works, we know what's going on. Threat modeling really has a real simple kind of process when it boils down to it. It sounds complicated, but it's not. We identify scenarios that could affect our assets. We get an overview of that. We identify those threats. We try and get those mitigations in place to defend against those threats, and then we test those to make sure that they work. Rinse and repeat. Keep on going on and doing that. So it doesn't have to be complicated. But the first part is, in security, I think a lot of our job is actually communication when it boils down to it. As we've experienced, I have done this myself, where we find vulnerabilities in organizations. We go back and do a pen test a year later, and we can just pull out the same report, blow the dust off, change the dates, and thank you. But we laugh and joke, but that's really the case. I've had customers where they're like, hey, that came up in the last pen test. It came up in the next pen test too. Example, I had a client where I found .git config on the web root in their development environment. Was able to clone everything, was able to find passwords, was able to get into the system. And they're like, hey, yeah, that was a discovery last year on production. They fixed it in production, but left it in testing. Yeah. And like I say, we can be forgiven for being popped by the things we don't know about, but we cannot be forgiven for the things that we do know about and keep on getting popped from. So it's important to continually test those defenses.
Yeah, so there's several frameworks you can use when you're doing threat modelling. Some of you may have come across these before. So Stride, that's made up from the initial letters of the various components of the process. Very common one. And Stride also tends to be sort of referenced within Pasta and Dread as well in the way of doing things. So it's a very kind of like at the root of how to do it. But quite an easy technique to use. And I've even seen it kind of applied to artificial intelligence because the aspects of it you can think of for different types of scenario. Pasta is a bit more involved, involves more sort of actually looking at those attack mechanisms and perhaps trying things out, being a bit more involved in the process. And Dread, while the top two are very qualitative, Dread actually puts some numbers onto things, so it's a quantitative one. But it's like that with risk management, isn't it? If you try and work out the potential cost of a risk, it tends to get quite complicated. But you probably do see that going on in very mature organisations, that they use very, very quantitative methods, whereas the majority probably stick with a qualitative of how bad does it feel.
Just to interject, they're not the only frameworks. They're just some of them. There's a lot more complex. If you're working with developers, Stride's pretty cool to work with, but I'm just going to talk a little bit more about that.
Yeah. So in Stride, the letters STRIDE stand for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. I always find it, when I first started doing it, I always got confused as to what the D stood for, because you think of D as disclosure, but no, you have to stick to D as denial of service, And then remember that the I is information disclosure, just so separate the two. But as you can see from the second column, those link to various security properties. And so where you need authentication, you've probably got a spoofing problem. Where you need to keep integrity, there could be a risk of tampering. And where someone may say, no, mate, wasn't me, that's where you've got a repudiation issue. Confidentiality, that's about encryption generally. That links in with the information disclosure. And then availability, so it's not just DDoS attacks, it can be losing your data once you've been attacked and not having backups, or your infrastructure, your hardware fails and you lose your data that way. That's an availability problem, isn't it? Or someone deletes something by accident. And then the elevation of privilege, which is down to authorization. So sometimes when you're sort of looking at a threat, you might find it a bit hard to think, where does that sit? And there are some which can kind of fit across the categories. For instance, if I steal credentials that I could potentially use to break into a system, but I'm not doing the break-in, is that a spoofing problem or is that an information disclosure problem? And I say it doesn't really matter too much, as long as it's made you think about the potential threat and you put it somewhere. I wouldn't get hung up about where things belong too much. When you're looking at those elements in the data flow diagram, it can be possible to kind of narrow down those stride elements to certain items within the data flow diagram. So a process, generally, they'll all apply to. But with an external entity, you can't have much control over some tampering going on a customer's device outside of your network while they're browsing your website. Spoofing a data flow is probably not quite so much an issue, But data stores, there's a bit of question there because if it contains logs, the data store could be involved in repudiation. And modern cloud data stores often have their own logging mechanisms, and so they do have repudiation considerations with them as well. But I find that a useful diagram to help see where might those various threats apply. Then PASTA, Process for Attack Simulation and Threat Analysis. And so that shows you the process you can go through. And so you see, it goes all the way through then to analysing the threats against the system's weaknesses and simulating potential attacks and then seeing what the risk and impact was. So, that's going to take a lot more resources to do, but could be a good thing if you really want to make sure, a critical system is properly secured, or if you've been a large organisation that has got the resources to do that.
That's what we need. We put in Dread, and it's not traditionally an attack framework, but I like Dread. Don't hold it against me. But I really like Dread with working with developers because I'm sure we've all experienced this problem of how do you express risk to people who are not risk sensitive. We spend our entire time thinking about risk. Threat and risk go hand in hand, right? So that's kind of the business that we're in. But the problem that we get is, I'm sure we've all been in enterprise environments, or for me, I do a lot of work with small and medium enterprises. And conveying risk is difficult because, you have your CVSS score and it's 10.0 or 9.9. And what does that actually mean? I may as well say to these developers, the score is 2 jet engines and peanut butter, because it's got the same context. It doesn't mean anything. And just because it's high in an environment that the disclosure wrote, doesn't necessarily mean it's going to be high in that environment either. So using Dread is a really good way of conveying risk with a team. There's a lot of different ways that you can use Dread. So you have this acronym, right? Like damage, reproducibility, exploitability, affected users, and discoverability, right? It's really not that complicated. But so you find a problem with Stride, or you find a vulnerability, or whatever. How do you discuss this with your developers? Do you say it's high, it's a critical, it's a red traffic light? Whatever the thing is, it doesn't convey very well for people. But what we can do is we can take something like this and use it to be able to make, I use it by having developers or myself write a sentence for each one of these issues that we find in the vulnerability. So to say, hey, this vulnerability is likely to damage our system and we lose the database. It's completely reproducible, and we can do it 100 times out of 100 times. It's easy to exploit. It's publicly available exploit code on the internet. It will affect all the users of this box, and it's really easy to find with Showdown. All of a sudden, I have an impact statement that describes that vulnerability that developers can express to their line managers, that we can express to developers, that makes it very simple, to be able to express what is actually going to be the impact. The benefit of Dread is that it's super subjective. It's for your environment. The failure of Dread is it's super subjective and it's only for your environment. And this is what I mean about that home field advantage. Dread, I absolutely love. I also use it in triage quite a lot as well. So it's not enough to find vulnerability. How do we prove it's closed? Well, we can use Dread in reverse. So the vulnerability is no longer disclosed. It's no longer discoverable. And it doesn't affect any more users anymore. And it's not exploitable anymore. We can't reproduce it, and there is no more damage. Now we've got it closed. It's a very, very simple tool. I've been a Linux freetard for a very long time, so it's very painful to take a Microsoft thing and give it lots of props. You could know with the name Finux, right? But as I say, I have found this to be super effective. It's not going to work in all of your environments. Some of you have far more mature risk management types of ways, but you can see how something as simple as this conversation can have a huge impact. And you don't have to use a sentence. You can have a traffic light, you can have a number, you can have a score, you can have whatever everybody's comfortable with. You can see something like this makes it easy for a developer to go, oh, it's going to affect everyone, it's got huge damage. This is definitely a medium vulnerability and we should get it closed. Whatever way that you do it, right? It's just management of risk, really. But that's what we can do, what we find through threat modeling and the stuff that we were able to prove with it.
Right, so yesterday I ran a workshop on threat modeling, so maybe some of you were there, and I was showing people how to use Microsoft's threat modeling tool. So I'm going to try now to give you a little bit of a live demo. It seems to be working, so I won't speak too soon.
Cross your fingers. Remember, traditionally, demo gods.
Yeah, he doesn't trust doing live demos, but there we are. So here's the tool. It is quite an old thing, and it's not very well loved. But I am in active conversation with Microsoft at the moment to try and get them to show it more love. So you can use templates. It comes with a few basic ones supplied. But you can also make your own. So this is one that we worked on yesterday. And you can put your own stencils in there for the type of infrastructure you have. So you can put in specific things for all the different types of components you use. If you're a SAP shop or an Oracle shop or whatever, put in all the relevant infrastructure. And when you're in these items, you can also add properties to them. So we've got there linked service types for the data factory, and that will be an option that the user can select when they're creating their threat model, which can then be used to feed into what sort of threats might be applicable on that resource. And these are the threat types over here. So you see they're organised in categories under Stride. Not in the STRID order here, but they are all there.
You can't have everything up there.
It's probably just because I haven't moved them into order. Sorry, I'm not as OCD as you. But here's the repudiation one, and here's one that we added yesterday. One little frustration with it is that it gets very OTT about sanitizing URLs. Anything that thinks could be dodgy, it goes and sanitizes, and so it turns all your HTML into codes. But if you're prepared to persevere and do a bit of find and replace afterwards, you can prettify it all quite easily. And I'll share some information for you later about that. So yes, you can put in there information about the potential threat. And I've garnered this from the best practice for this resource. So, cloud providers, they publish all their best practice for each individual resource. But the trouble is people don't go wading through it, do they, when they're building something? But this provides a nice way to bring that out. And the other thing is you can add to it as you get incidents, as you get pen test findings, anything where you think, oh yeah, we should have thought of that. Well, if you can make a suitable rule that when you've got this resource and this situation, then this could be a threat and you should have a look, you can build it into this template. So I'm just going to show you a sample model now, again, the one we did yesterday. So there we are. Looks a bit like the data flow diagram, except that this allows you to actually put some stencils in that look a bit like the ones that you're familiar with for the cloud. Some of these are very old, but you can put modern ones on yourself. And so you can then, show how these resources connect together. And you might find with some of them that you get options down here where you can select, there we are, how that resource is connected and configured, so that you can then bring out any relevant threats. Then once you've done that, you can go into Analysis View, which shows you a nice list of everything. It's possible to click on something, and if you do decide it's gone a bit OTT and no, that's not really relevant in your situation, then you can actually select it as not applicable, and then you can choose later to just report the applicable ones. And you can also set a state of mitigation on these things as well. And there's a nice export CSV button here, which can be useful to get a summary out of everything that needs addressing. I'll go back to my design view. And so then if you go to reports, you can create a full report, and then you can choose what you want to include in there. And in good demo style, here's one I did earlier. And this one's been tidied up to get rid of all that OTT sanitization. But there we are, got a nice diagram, and then it breaks the diagram into interactions and brings out all the information that's been entered into the template for that particular resource with that type of interaction. So I think that gives a nice summary, all the information a developer might need to go and look at how do I address those particular threats.
Just now get a round of applause for doing like a demo.
Right. Here we are. Back to you now.
Oh, back to me. I have to talk about Threat Modeling Manifesto. Oh, cool.
Sorry.
You have this weird thing here. Is this me or?
No,
oh, there we go. So, the Threat Modeling Manifesto, it sounds a little bit like some rebellion going on, right? Like, it's not that complicated. The Threat Modeling Manifesto could be distilled down to really kind of like 4 type of questions that are asked. But it just kind of goes through I'm not going to go through everything inside of the Threat Modeling Manifesto, but the long story short is this is the combined wealth of a number of rather large famous threat modelers over the years going through what their experience is about how to make that work. Does it align? How easy is it to do? But I think probably one of the most important questions that come out of threat modeling really is asking people, the Threat Modeling Manifesto has one of the questions of, did we do a good job, right? Like when we go through, did the mitigations work? Did we develop it? What are we trying to achieve? so on and so forth. But the main question is, did we do a good job? I think Adam Schustak has a really good kind of play on that later on, where he asks people, would you do threat modeling again? And of course, if the answer is no, then there's a problem in the threat modeling, because it's become inaccessible. People are not understanding, they don't see the benefit of it. So I think when you're working with people with threat modeling and delivering threat modeling, we should always try and remember to ask people, is this something that you would do again? Are we doing a good job? Not just from the development perspective of fixing that problem, but as threat modelers. Because it's not rocket science. This is just a methodology to try and work out what problems are. We're not going to find everything. But the more that we talk about it, the more that we start to kind of get in depth. It's weird because I went probably 15 years in my career without ever doing any threat modeling whatsoever at all, in a bunch of security testing in large organizations, and I always feel that nobody is really threat modeling effectively. And I think now we're starting to see an increase about why this is important. Watch out for AI-inspired threat modeling, though, because there's definitely a model for that somewhere. I've spoken to a few companies already, and there's some interesting tools out there that may or may not find threat modeling. So good luck asking ChatGPT if it's good and do it again. But in a lot of ways, threat modeling, so if you get a chance, go and visit the Threat Modeling Manifesto. It's going to take you about 5 minutes to read. It's not very complicated. I think it literally is threatmodelersmanifesto.com.
Threatmodelingmanifesto.org, I think.
Okay. And as I say, but I would say, what is it that we're trying to achieve is probably the first question that you should be asking yourself, right? What is it that the point of the application, or, threat modeling doesn't just have to be for web apps or for applications. Threat modeling can be anywhere. We do threat modeling naturally when we leave the house. We do threat modeling when we naturally look out the window and see rain and remember to take our coat, although we're not doing that today. You probably did some form of threat modeling when you left the house and went, oh, it's hot, I should put shorts on. But at the end of the day, threat modeling is around in everywhere. So, trying to remember what is it that we're trying to achieve, but also at the end, asking yourself, was it effective? Did we do a good job? Would we do it again is super important.
So I've got here a few useful resources for you. There you are, it is threatmodelingmanifesto.org.
Okay.
I did wonder if I'd got it right. But there's some links there as well for the main cloud security best practice. So they're sometimes a little bit hard to dig out. They don't both do it in the same sort of format. And the MITRE CAPEC mechanisms of attack one is a particularly interesting one. A guy called Brett has broken down MITRE's common attack patterns and linked them to the elements of Stride. So it can be a good way of looking at those various attack patterns to give you that inspiration, get your juices going on those kind of unknown knowns, on how your application may be attacked. And again, if you want to try the threat modelling tool, something maybe you can build into that. And so there's a bit more information there on the relevant MITRE stuff. And then if you actually want to use the threat modelling tool, you'll need some icons. So I've just put some handy links there to some of the available icons for AWS and Azure. One little note, though, on the icons is that Azure ones come in SVG format. The threat modelling tool only likes PNG. So I tend to open it in the GIMP, change the size to 72 by 72, add a white background, and then export it as PNG. And that then works quite nicely. So I work for Sainsbury's. We're likely to have some roles available soonish. Keep an eye on LinkedIn. And you can follow Sainsbury's.jobs, see what you have in the way of information security roles. I'm on X, and I tend to tweet a lot of kind of breaking information security stories as I spot them. And if you want to use the QR code, and it is safe,
Never going to give you up.
That's a link to my GitHub where there are some goodies from yesterday and also a PDF copy of these slides from today. So hopefully you'll find some things in there if you want to get started. I don't think I'll put the threat modelling tool link on there, but it's aka aka.ms/tmt. Very easy. But just Google Microsoft Threat Modelling Tool and you'll find it. But have a play. It's free. It's very customizable. And you never know, you may grow to love it eventually.
But there is a lot of resources on YouTube too. You don't have to use like Microsoft's tool. Draw.io also has threat modeling icons inside it too. Really simple to do, something that's super fun to sit down with developers and get them to put out their application and work through. And you can find lots of YouTube videos that will walk you through how to do like DFD1 or DFD2, level 1, level 2. They get far more complicated as they go up. But, you don't have to get in depth. But the Microsoft tool is very cool. I'm not sure if any of you have played with any of the other open source free sort of tools, but it kicks the ass out of ThreatDragon, for sure. And like I say, with Draw.io, you don't get all of those threats and all of those kind of predetermined stuff. So, like, some cool stuff in there. So I think for us,
yeah.
We're done. So.
Any questions?
The dread where you got highlighted it. Might just be really random, but is there a matrix that provides guidance on how far along you are in that model?
Well, that's the subjective part of it, right? I mean, you can kind of like, I guess for me, I just inherently have a guess and hope for the best, right? Like, there's no kind of like, it's only half damage, so we're only going to put half the stars in. But I guess you kind of have to sit there and say, is the damage going to make it unavailable for an afternoon? Or is it going to make it gone forever? But this is something that we can update and negotiate within those teams that we're doing that kind of subjective kind of feedback with and say, do we agree that this is damage? How bad? Or is it, reproducible is pretty easy, right? Like, can we do it? Can we do it 100 times out of 100? Or can we only do it 50 times out of 100? So we kind of get a rough idea. But like, why I like Thread is because it's a communication tool. Yeah, right.
So it's probably more of a question for you since you have customers. You've talked about the nodes and getting them to comprehend the risk example. How do you fight the other part of threat modeling, which is but necessary?
Well, my experience here is if you can offer somebody an out where because Nessus might say it's a red, right? But in your environment, like Nessus might say that it's super discoverable, but in your particular case, it might be in a restricted environment that isn't discoverable. That's the quantitative approach with Dread that you were able to take. I'm just going to shut the store for a second. I have ADHD, by the way. I'm not sure if you guys have noticed, right? But like, I get distracted very easily. So, but yeah, I mean, I guess the real problem with that is when you say it's safe and Nessus says it's red, or Nessus says it's green and you say it's bad. And that's probably the other way around, because my experience is companies want to do as little as possible. It's that saying in the movie 300, lessons not learned, blood is soon forgotten, right? But in pen testing, what I've learned is customers who have been compromised are far more capable of understanding risk than customers who haven't realized they've been compromised yet. So they're always looking for but it's safe. I invested 50 grand in security tooling last year and I didn't get hacked. Why do I need to do it this year? That type of thing. But the subjective nature of that statement, for me, I use it to build that impact statement. And I think that's where the effectiveness is, because you can be a CFO and understand that. You can be a business analyst and understand that it's going to damage our system, it's going to affect our customers, and that's so on and so forth. I don't know if that answered your question.
Yeah, I mean, I think having the red lines is probably better, but in my experience it's you give the report to a C-level person and they go, but Nessa says that's a burnt sienna on the deluxe colour chart. Bad and failed.
That's your problem, getting a necessary report to a C level.
Executive
I
summary.
didn't say I did.
Executive summary should be on fire.
Yeah, so I just want to first say thank you for the great talk. One of the things that I just wanted to sort of just add to the talk was that really the thing with threat modeling is that it's about the concept, not the exact methodology you use. The whole point of it is about doing the breakdown, moving away from what your manager is often wanting, the ticky box security, no reds. We tick the box, say no reds. That as an industry, like the automotive industry has moved away from that, the MOD has moved away from that, both of them are moving to secure by design. The idea of doing this threat modeling process to understand the risks, and if any of you are working in security architecture roles and you're not currently doing threat modeling, you're going to have to be doing it soon, because that's the way the industry is moving as a whole. And there are other techniques, such as the one that I like using, is the Carver approach, which is great for a high level before you even begin. Do I even care? How much effort I put in? And I get to preface it with we only want to do the work that matters, to make sure we're spending the money in the most effective way. So I'm not here to be security says do a lot of work. I'm here to be security says you don't actually have to do a lot of work. So with things like that, a lot of it is about establishing the risk and having a methodology. The great thing with threat modeling and the approaches we put here is that we can appeal not to I doodled a diagram, but to I use the stride method, because then it sounds like you're using an official tool. It's clever. So that's what's really useful to do with cases like that. Because often it's not the board person going, I want to tick the box saying no reds. I also encounter, I'm sure Finux will talk about that as well, I've encountered a lot of developers who are like, panic! Panic! Everything's on fire! I'm going to fix this right now! And then you have to sit down with them in the next meeting and go, okay, but that wasn't on the critical path, it wasn't a major issue, and in fact, you've avoided the really major issue I identified and spent all your time instead on this thing that will physically never happen. So that's where using these methodologies comes in really useful. It's about bringing people on board with the idea that we're trying to address this now, not in a pick your vulnerability and patch it way, but in a which one do we want to do? What is the correct way of solving the problem by applying threat modeling methods?
Super.
Right, well, we've got to 5 o'clock, so we use the time. Oh, sorry.
I think we can probably pull off what.
Yeah,
Are you the next speaker?
No, I'm waiting for it.
Okay.
It's break.
Is it break? Okay.
Oh, yes, right, sorry.
No more questions then. You all have to go. Get out.